Welcome to the deep dive. Today we're focusing on an industry that's absolutely foundational to our future mining.
Hmm,
Think about the copper, the lithium, all those crucial elements we need for the global energy transition. It really all starts here.
it does. But it's an industry under, well, immense pressure.
Yeah, we're talking about really high stakes, inherently dangerous environments, and multi-million-dollar machinery. Huge stuff.
Absolutely huge.
We've spent some time pulling key insights from sources, looking at EON Reality's launch of their mining workforce training segment. It's part of their XR Library Premium.
Right, using XR augmented and virtual reality.
Exactly. And our mission today is to understand how this spatial AI-powered simulation tech is moving past just being, a novelty. How is it becoming a critical operational tool? Specifically, how is it tackling that really tough combination of challenges mining faces?
That terrifying trinity, as you put it.
Yeah, safety, the astronomical costs, and the urgent need to fill the skills gap fast.
Yeah. And what's fascinating, I think, is how acute those pressures have become
Mhm.
all at the same time. It's not just one thing.
Right.
We're looking at this critical convergence point. You got the undeniable safety risks. I mean, sadly, fatalities still happen. Collapses, gas, machinery failures.
Mm-hmm.
Then second, the equipment involved is just incredibly capital intensive. Assets costing anywhere from, say, $5 million up to $20 million per machine.
Wow.
So any mistake by someone new, it's financially catastrophic, or it could be.
Yeah, you can't afford that.
And third, the industry is really grappling with an aging workforce, and this huge demand for accelerated upskilling. Traditional methods like classroom learning, they just can't deliver.
Not at the speed or the safety level
No.
needed now.
Exactly. Not anymore.
That makes total sense. I mean, you can't just put a new operator on a, $5 million haul truck and just cross your fingers. They learn quickly. And you definitely can't run a real fire drill deep underground every week. It's impossible. So that traditional training approach, the classroom, the dusty manual, maybe a bit of time in the field, it just feels totally insufficient for the complexity and the consequences today.
It really is.
Okay, let's dig into that cost factor a bit more. If a company invests, say, millions in these fancy XR simulators, does that initial cost truly offset the risk of training on a real $5 million truck?
Oh, absolutely. The sources are pretty clear on that. And it's not just about the risk of, wrecking a machine, which is bad enough.
Right.
There's the operational cost, too. If a maintenance crew takes too long on a fix or maybe doesn't do it quite right, that massive machine is down.
And downtime costs money, a lot of money.
Millions annually in lost production, potentially.
Yeah.
The margins for error are just razor thin. That's why that old-style limited field training often falls short. But even that financial risk, as big as it is, it's still secondary to the safety side of things, the safety imperative.
Good deal.
People first, always. Traditional classroom learning just cannot adequately prepare someone for a critical emergency,
Right.
like a sudden high wall collapse or unexpected gas exposure.
Things that happen instantly.
Exactly. When lives are on the line, the training has to be repetitive, totally risk-free, and build absolute, muscle memory.
Instinctive reactions.
That's the level of competency you need.
Mhm.
And it really only comes through simulation, where the danger is gone, but the pressure and the complexity, they're still there.
Okay, so that structural need for high stakes but risk-free training must be why this XR library segment breaks down its curriculum into four distinct areas.
Yeah, the sources mentioned 4 key groups.
Safety and emergency, operator competency, maintenance, and then leadership. Why those specific 4? Which one do you think was maybe historically the most underserved by traditional training methods?
That's a good question. I'd argue leadership has often been the most overlooked, sort of the soft skills part. But the 4 areas together, they really cover the entire operational ecosystem.
Yeah.
You have to make sure the worker knows how to survive an emergency, first off. Then how to run the equipment safely and effectively. Then how to keep that expensive equipment running. And finally, how to manage the human element, the crew, successfully.
So it's a holistic approach, managing all the risk factors.
Exactly. A holistic approach to risk management.
Okay, let's start where the stakes are literally highest, saving lives. Group A is all about safety procedures and emergency response.
Right. And this is non-negotiable. Mines are fundamentally unforgiving places. So safety training has to be, instinctive. It can't be something you look up in a manual during a crisis.
No time for that.
No time. And XR allows crews to rehearse these complex, high-stakes emergency procedures, things that would be just impossible or far too risky to practice in the real world.
Like what specifically?
Well, core stuff like mine evacuation protocols,
Right.
practicing finding your way through, say, dark, possibly damaged tunnels,
Yeah.
locating refuge chambers, critical survival skills, or things like underground firefighting techniques, smoke management, or running drills for hazardous atmosphere detection, reacting to methane or carbon monoxide exposure.
That power of repetition in these, frankly, deadly scenarios really seems key. I was struck by one detail in the sources.
Which one?
Mentioning crews rehearsing a methane gas event in XR over and over until the correct response steps are just completely automatic.
Yeah, that's the goal.
Because in a real emergency, that automatic response prevents that fatal hesitation. It turns knowledge into pure muscle memory.
And that's often the difference between life and death underground. Truly.
So, okay, we've ensured the worker hopefully survives the emergency. Now let's make sure they don't cause one by, say, wrecking the equipment.
Right. Which brings us nicely to Group B, heavy equipment operator competency.
And the goal here seems pretty straightforward.
Oh.
Master the multi-million-dollar machinery using digital twin practice before going live.
Exactly. This is where you protect those massive capital investments. They're simulating operating everything from haul trucks and excavators.
The workhorses.
Yeah, the everyday workhorses, up to the real behemoths of the industry, like the dragline excavator.
And when we talk about a dragline, I mean, we're not just talking about a big truck. This machine can be the size of a, 20-story building.
Easily. Incredibly complex, and yes, often cited as one of the single most expensive assets on a mine site.
Its sheer scale and complex movements mean the learning curve in the real world must be brutally long and expensive if things go wrong.
Oh, incredibly so. So here, you're teaching precision handling, load management, sequencing, all in a safe virtual sandbox.
No real-world consequences for mistakes.
None. I was actually struck by one specific number I saw mentioned.
Yeah.
It talked about a new operator completing over 100 practice cycles in XR haul trucks before ever stepping foot inside the real $5 million vehicle.
100 cycles, wow.
Yeah, think about that. It dramatically cuts down the risk of a catastrophic error, and, maybe just as importantly, it accelerates their readiness. They can be productive much sooner, much safer.
You just cannot get that level of consequence-free repetition with traditional on-the-job training. Not possible.
Not even close.
Okay, so protecting the equipment, that leads us directly into the next priority. Keeping things running, ensuring operational uptime.
Right. Group C, which focuses on maintenance technician upskilling.
Because mining operations, they need continuous running time, right? So this training has to prevent costly downtime.
Exactly. By focusing on systematic workflows and more advanced diagnostics, this moves the training beyond just basic mechanical know-how.
So what kind of things are we talking about?
Well, complex system maintenance, things like crusher and conveyor belt maintenance, diagnosing tricky hydraulic system problems, dealing with specialized electrical systems like switchgear and motors.
Complex stuff.
Very. But the real sophistication, I think, comes from using that digital twin concept for the highly complex, high-cost tasks.
Like what? Give me an example.
Okay, like practicing a full powertrain overhaul for a massive haul truck, entirely in VR. Rehearsing every single step, every bolt, before you even touch those enormously expensive physical components. Minimize the risk of error, minimize the downtime.
Makes sense.
And they're also including training on how to use and respond to predictive maintenance data, data coming from IoT sensors on the equipment.
So getting ahead of failures.
Precisely. Preparing technicians to preemptively fix problems before they cause a breakdown rather than just reacting afterwards. Big cost saver.
So we're keeping the physical machinery running smoothly. But as you said, the machine's only as good as the leader running the crew.
True.
And the training addresses that human system too, right? In Group D, mine site supervisor and leadership training?
Yes, and this is that area that, as we discussed, historically might have suffered the most because you can't easily simulate a bad interpersonal dynamic or a failure of safety culture in a classroom.
Mm-hmm.
It's hard.
Yeah, how do you practice that?
Well, the examples here are quite interesting because they're essentially soft skills, but wrapped in this very high-stakes mining context. Things like practicing pre-shift toolbox safety talks. How do you lead those daily briefings effectively, get the message across? Crucial interpersonal skills like conflict resolution for mining crews, that happens.
I bet it does.
And ensuring smooth, really clear crew communication during shift handover protocols. So much can go wrong there if communication breaks down.
That handover is critical.
Absolutely critical. And maybe the most vital simulation for building that safety culture is how supervisors use XR to run incident investigation simulations.
Ah, okay. So after something has gone wrong, virtually.
Exactly. It tests their ability not just to react to a problem, but to really dig in, analyze it, identify the root cause accurately,
And then,
and then proactively enforce the necessary corrective actions to prevent that same incident from ever happening again.
so you're building complex leadership decision-making skills.
Yes. In an environment where failure just means hitting reset on the simulation, not, a hefty fine or worse, an actual accident.
Yeah.
So if we kind of step back and look at the big picture, this whole XR approach, it really feels like a total paradigm shift for training in this industry.
How so?
Well, think about it. Before, safety drills might have been run, once a year, infrequently anyway, because of the inherent danger and the cost involved.
Right.
Now, you can have frequent, totally risk-free XR simulations building that critical muscle memory we talked about.
Okay.
Before, hands-on training was often limited to when equipment was already down for maintenance.
Yeah.
You had to wait for an opportunity.
Which isn't ideal.
Not at all.
Yeah.
Now, you get continuous skill rehearsal on these virtual assets whenever needed. And this whole transition is really enabled by the specific technology they've built into this platform.
That's the part I wanted to unpack a bit more. It's clearly not just, a fancy video game. What makes their spatial AI coaching different?
Good question.
How does it go beyond just simple scoring or like a basic checklist? Does the AI coach actually understand why someone might be making a mistake, or is it just grading pass-fail?
It's designed to be much more than pass-fail. It aims to be an adaptive, intelligent tutor.
Okay.
So it's not just scoring you. The idea is it's providing real-time correction based on known failure patterns for that specific piece of equipment or that specific emergency procedure.
Ah, so it knows common errors.
Yeah, the spatial AI tracks your movements, your decisions within the virtual space. It spots inefficiencies or deviations before they become critical errors. And then, crucially, it can adjust the challenge level.
How does that help?
It forces you to confront your specific weaknesses. It's kind of like having an expert instructor looking over your shoulder 24/7, adapting the lesson just for you.
And for an industry that's so heavily regulated like mining, the training has to be, well, verifiable, right? You need proof.
Absolutely critical.
Yeah.
The sources emphasize adherence to industry frameworks.
Good one.
Things like MSHA, that's the Mine Safety and Health Administration here in the U.S., the gold standard. Also ISO standards and zero harm frameworks.
So the modules are aligned with what regulators expect.
Exactly, they're standards aligned. That provides the external verification needed for compliance. And crucially, they track and record every achievement using something called verifiable credentials, meaning you get these secure digital records that track individual skill mastery. So there's absolutely no guesswork about whether a worker is truly competent in a specific high-risk procedure. You have the digital proof.
Got it. And the final piece seems to be deployment flexibility. Mine sites can be incredibly remote. Connectivity isn't always great.
That's a huge factor. Accessibility is paramount. You can't have a great training tool that no one can access.
Right.
So this training can be deployed pretty much anywhere on a simple tablet, a lightweight VR headset, or even a standard desktop computer. And critically, it works both online and offline.
Offline is key.
Essential for reaching workers who might be operating deep underground or at remote surface sites, far from any reliable high-speed internet.
So, okay, pulling it all together, what does this really mean for you, the listener, thinking about this space?
Well, it seems this platform synthesizes these key needs: improving safety, reducing those massive costs, and accelerating skills development.
Yeah.
By giving the workforce the tools to practice and, importantly, perfect these highly complex technical and emergency skills in a completely safe, repeatable environment. It's about dramatically de-risking operations in one of the world's most critical and historically dangerous industries.
#tag outro.
Yeah, it's truly compelling to see how this immersive technology is evolving. It's moving past just being a cool gimmick or a novelty.
Oh.
It's becoming a measurable, critical tool for operational precision and safety. The core achievement here really seems to be giving that workforce the ability to practice and perfect those vital skills without the terrifying risk of lost lives or million-dollar machinery damage.
It really is significant. And this raises, I think, an important question for you, the listener, to ponder. If these complex, high-stakes operational roles, like in mining, can now be effectively mastered through this kind of immersive, verifiable digital twin practice, What does that really mean for the future of specialized critical training in every other dangerous or high-cost industry?
Good question. Like what?
Think about nuclear power plant maintenance, or maybe high-altitude construction, complex surgery. Anywhere, mistakes are incredibly costly or dangerous. If mining can do it, who else? And maybe more personally, what specialized skill set could you benefit from practicing over and over without any real-world consequences?
Something to think about.
Definitely something to think about until next time we dive in.